Hello everybody, this is the notes for section 2.4 honors geometry. Going to be using some postulates, which if you remember are statements that are just kind of accepted as true. There's no real proof required for them. But going along the lines of what we've been talking about, making statements, trying to justify our reason, why our statement is true. But we're going to be using postulates to do that. Kind of goes right along with the idea of deductive reasoning. We're making a conjecture, but it's based off of known things, not guesses of patterns. And we're going to look at some diagrams and see what we can and can't do with certain diagrams, what we can and can't say. All right, you're going to want to hit pause on this. You are definitely going to want to have these in your notes. Even write down the numbers. You don't have to memorize them. As far as postulate 5 is, through any 2 points there exists exactly one line. Really, the numbers are going to be a reference in some of the homework problems. They may ask you to say, yeah, this is postulate, or use postulate 5 to verify this or that. So it's really just a reference, but you don't have to memorize the specific numbers. But take a second, copy those things down. Most of them are things that we've talked about before. Okay. So just, I guess, a couple of words about these. Like I said, most of these are things you've talked about before, we've talked about before. It's looking like a couple of them are just kind of like the converse of each other. Through any 2 points, there exists exactly one line. Well, postulate 6 is a line contains at least 2 points. Very similar to each other, but we're just kind of going in different directions, the idea of a converse. Okay, so here's the idea of some of the problems that you might see. Okay, sorry, had to hit pause. State the postulate illustrated by the diagram. So what you have is, if you have 2 points, then, well, now you've got a line going through those 2 points. So if there are 2 points, then there is one line going through them. So just going back to reference this, through any 2 points, which is what we have, there exists exactly one line. That's our postulate. So why can this statement be made? Because of postulate 5. Through any 2 points. That's your points, A and B in the picture. There exists exactly one line. And that's our line AB. Okay, so we're making this statement. We know this statement is true because of this postulate. That's the idea of deductive reasoning. We're making a statement, but it's backed up with known things, or things that are believed to be true and accepted as true. For part B, we have a plane R. We have 2 points on that plane. That's our condition. That's our given stuff. Sorry, I had to pause again. I had to sneeze. So we got a plane. We got 2 points on the plane. That's our hypothesis. Then we're adding a line also on the plane. So if we go back to the list of our postulates, why can we throw that line on the plane? It says in postulate 10, if 2 points lie on a plane, that's what we had in the picture, then the line containing them, those 2 points, lies on the plane also. And so that statement can be verified with postulate 10. We have the 2 points on the plane. We now have a line on the plane. And we know that line is on the plane because of that postulate. Okay, this is a very, very important picture, an idea here. This kind of thing has been happening in some of the homework problems for some of you, and it's going to continue happening. Hopefully not. The idea here is, given a picture, what can you know for sure and what you cannot assume? So I want you to take a good look at these 2 lists. In that picture, with only the given information, look at the things that you can assume from the picture. And then take a look at the things you can't assume. Start thinking about, okay, why can't I say these? So hit pause, take a minute to look at this. All right. So I really want to talk about the things that you can't assume. This first one, points G, F, and E are collinear. There's G, F, and E. There is no line drawn in there. It looks like they might be all in the same line, but because there's no line drawn there, you don't know for sure. You cannot assume that. Line BF and line CE intersect. It looks like this one has a little bit of a different slope. If we continued it this way, we continued this that way, it looks like they might connect eventually, but again, you don't know. And same thing going the other direction. These are close enough to being parallel. It looks like they might just continue on forever being the same distance apart, being parallel. But again, there's no information there that you can say, oh, definitely, these are not going to intersect. You just don't know, so you can't make those assumptions. All right, angle BA or BHA. Is that angle is the same thing as angle CJA. Boy, they look like they're the same, but again, there's no information there to tell you. If there was, the thing you'd be looking for would be this little arc saying, yeah, those two angles are congruent to each other. We don't have that arc. You can't say those angles are congruent. All right, the whole idea here is what are you assuming is true and what you cannot assume is true. Okay? I guess the last one, line AD is perpendicular to line BF. Perpendicular, you'd be looking for that little right angle square kind of thing right there at the vertex, or angle AHB is 90 degrees. It looks like it might be, but again, no information there to say, yeah, this is true. All right, so you cannot, if that information is not there, you cannot assume that. Okay, so kind of going off of that idea, which of the following cannot be assumed from the diagram? So basically, true or false. So hit pause, take a look at the picture, look at some of the details, and then can you assume each of these statements? All right, so for the first one, it says points A, B, and C are collinear. That is true. You've got this line drawn in there. All 3 points are on the same line. The next one, line EF, perpendicular to line L. Let me clean up the previous one. All right, this is also true because of that little perpendicular marker right there. It is connecting line EF to line L. That's where that perpendicular marker is connecting those two parts. That means they're perpendicular. Okay? So again, there's information in the picture that says this is true. We're not assuming anything, it's right there. For the third one, line BC is perpendicular to plane R. Okay, plane R is this vertical-ish kind of plane. Line BC is this line here. There is no perpendicular marker. We got the perpendicular marker on line EF and line L, but BC, there's no information there. We cannot assume that, so this would be false. If it were true, what you'd be seeing is something like this, where there's perpendicular marker connecting the line to line L that is on that plane. It could go from line AB up to line EF, but again, we don't have that information there, so we cannot assume that. All right, so let's see, we're on to number 4. Line EF intersects AC at point B. Two lines intersect at a point. EF and BC are intersecting there at point B. True. All right, the 5th one, line L is perpendicular to line AB. Okay, this is line L. Line AB is there. We don't have any perpendicular markers connecting those two lines. We cannot assume that. That's got to be a false. And the last one, points B, C, and X are collinear. Now, it doesn't even look like it, but again, there's no information there that says, yeah, X is on that same line. You cannot assume that, so that's got to be a false. Okay, this is the idea. We just got to make sure that whatever statements we're making, they're verified. They're backed up with information in the picture, known information. They're backed up with the postulate that says, yes, this is true. Okay, that's the idea. Have a good night. See you tomorrow.